I happen to be quite a decent developer. I'm senior dev and team lead at Safetica. And I also like to write articles about C++ and related topics. And today I wanted to revisit an older topic of mine, which is about initialization of class attributes. And on itself, it's a really boring topic, but I spun it into compiler optimizations and certain C++ 23 features. So I think there should be a little bit for everybody, right? Before we start, usual disclaimers apply. There will be slide where I might have made mistakes while copying it into the slides. There will be C++ 20 and 23 features in the code, so they shall be pointed out as such. And since this is inspired by an article, there will be a link to that article at the end of the talk instead of link to the slides. A little bit of motivation to get us started. Imagine you have some big or expensive to copy data type, and you want to store it inside of a class. Now, you want to pass it in closer. OK. Sorry, everybody. You have some expensive to copy data type. You want to store it inside of a class. You want to pass it in through the parameters of the constructor. So what is the most efficient way of doing so? Right? If you didn't give it much thought, you would probably use const, or maybe for whatever reason you want to use rvalue reference. We'll try both. We'll try a little extra and figure out what's the best, what gives us the most flexibility and the most performance. But before we get to that, little quiz time. Please hands up who thinks that compiler is allowed to optimize away, under certain circumstances, your business logic, even with optimizations disabled, and there's no undefined behavior involved, right? This is not a trick question. Do you think compiler is allowed to optimize away your business logic? Hands up, please. OK, a few hands up are going up. Great. Yes, it is true. For example, compiler is free to elide copy and move constructors in cases of certain optimizations, such as named return value optimization. And it will be relevant later in the talk. For now, it just allows me to write a simple tracer class which logs its copy and move constructor. And based on which of these constructors are logged and when and in which quantity, we can figure out what is the optimal solution for our case. Note that there is std println, which is a C++ 23 feature. It is a great feature. I recommend using that. Note that tracer is 8 bytes in size currently, but even if it was like 2 kilobytes in size, most of the slides wouldn't have to change. There will be one slide affected at the end of the talk, so I will point it out. Then we have our test cases. We have this tracer class that is logging its copy and move constructors, and we will be passing it down to some tested class to its constructors. And there are basically 3 major ways how you can pass it in. First of them is rvalue. You have a regular variable. You're passing it down to the constructor. Or you can have rvalue, which is a pure temporary. You can see it is instantiated directly in the parameter list of that constructor. It has no assigned named storage. That's why it's pure temporary. And rvalue, that's a named variable that has been moved from. So we have 3 basic cases. And now we have some benchmark cases to get us started. As I mentioned in the beginning, there is a const version accepting the parameter by const. Then there are 2 by value versions. One of them is simply copying. The second one is moving. And the 4th constructor is taking by rvalue reference. So if we plug it all in, what do we get? We get this table, copy and move constructors logged. As you can see, for rvalues, we can't really get better than just copying that value, obviously. If you use the constructor that only accepts rvalue references, you can't accept by rvalue. In that case, you need to You need to explicitly call the copy constructor to create a temporary, and then it falls into the PR value case. From the slide, you can also see, I hope I'm not obfuscating it too much with my hand, you can also see that the rvalue version of the constructor is the most efficient for PR value, and rvalue, it just does the move. And the constructors that are accepting the value by value, they're nothing to write about, nothing to write home about, right? Ideally, I would like to have some solution that would give me the one copy on rvalue and the moves on PR values and R values like in one package. And it turns out it is really easy to do so. I just define two constructors, and the compiler will pick the most optimal one. If I run it through my test scenarios, I get this, I'm happy, right? Not really, because this doesn't scale up with the number of parameters. Obviously, the number of constructors will grow exponentially if I choose this route. So, is there some other way to achieve this? Well, yes. I have to use templates. And I have to use templates due to a decision in a C++ standard that I don't particularly fancy, because there is a feature called universal reference. It is also known as a forwarding reference because you are using it with the std forward helper. And for whatever reason, C++ standard uses the same syntax for rvalue references and universal references. That means 2 ampersands. And the differentiator is that if it has a concrete type, then it is a rvalue, and if it has a templated type, it is a universal reference. And in this particular case, I would really like to use a universal reference with a concrete type. However, I cannot do that easily. So in this case, I can use this templated constructor, and it will work just fine. std forward preserves the value category of the parameter that is passed into the constructor. But obviously, from the user standpoint, like if you don't write documentation, then they don't know what to put in. So can we improve upon this? Sure. We can use a really nice C++20 feature, and we can restrict the API to accept only certain types. In this case, it only accepts types that are either same as or convertible to my tracer class. And this is somewhat more legible, but then again, if I have multiple parameters, this will quickly grow in size. So, another quiz time. Can we do this as a one-liner? Does anybody have an idea how to turn this into a one-liner? Shout at me.
Remove the same as.
Once again?
Remove the same as.
Okay.
And then you can use std convertible to auto double ampersand.
Okay, you're getting close actually. Another idea.
Remove the template and use auto with the concept in line.
That's what I said.
Okay, thank you. Yes, the answer is concept and constraint auto. Thank you for that. I have very intelligent audience here tonight. So first of all, take the requires clause and refactor it into a concept. Concept is reusable, and you can also specialize it. So we can create a concept for universal reference, sort of. The first templated type is what will go in from the type that is passed into the constructor, and the second target type is specialized whenever I use this concept. As you can see in the template down below, the class keyword was dropped and replaced instead with the concept. The tracer goes into target type, T goes into T. And if I use constraint auto, as it has been recommended, remember, auto in the function parameter list is the exact same thing as if it was a templated type. And I can just prepend it with the concept, turning it into one-liner, and now I'm happy, sort of. I'm still using templates. I'm not happy altogether, but I'm as close as to happy as I can get. And this scales well with the number of any number of parameters, right? during everything that I just said, you may have a question in your head. Why not just use move? Like, if, as I said, the type is expensive to copy, why not just restrict our constructor to only accept rvalue references? Because in that case, any copy needs to be explicit and can be reasoned about. I think, like, while this mindset of restricting what I can do and making the copy explicit is a good direction, I don't think it is a good idea to create move-only APIs in our C++ code. Because in this particular case, that expensive to copy type should be a black box, and outside components that consume it shouldn't be like aware of its internal implementations, so they shouldn't impose a particular way of using it. Also, C++ is not Rust, and I don't really trust use after move diagnostics. Call me paranoid. So instead, I would suggest if the type is really expensive to copy, turn that copy into explicit thing by making the copy constructor private and expose a clone method. In my eyes, this is a better solution. Another question that you might have is, do PR values really matter? Like, how often do they happen in our production code? Because in unit tests, where each test is written for a particular case, we can create a lot of temporaries right in our function calls, because we are hard coding values for that particular tested case. But in production code, most of the configs go from user input or database or network or whatever. Do PR values really happen in our production code? And I would argue that in a certain class of methods, they do. And this class of methods are factory methods. And this is where compiler optimizations really come into play. Because I have this create tracer factory method, and the implementation is in a completely different compilation unit from where I'm using it. And even though it is in a completely different compilation unit, I hope you can see that in the comments, there are no extra copies. There is only one copy for copying it into the from the constructor into the attribute, and move for the uniref version. There are no copies for getting the tracer out of the create tracer function. And this is due to optimization called name return value optimization. Really simplified, it basically creates the space for the tracer in the address space of the caller, not the called factory function. And the called factory function is just told, hey, there is some space, you can fill it with data. Like, I don't know how many of you coded in C++ like before C++ 11, but back then, when this optimization wasn't mandated by the standard, many so-called factory functions required you to create an object ahead of time and pass it in through an in-out parameter that the exact same thing, essentially. This is just more convenient and preserves the temporary that can be then efficiently passed down to another functions. You could also have an idea that if my object is expensive to copy and I'm creating it inside of a factory function, I will preemptively move it in my return statement, right? Just to really prevent that copy from happening. However, that would be something called pessimizing move, and I really recommend turning those diagnostics for that, because when the compiler is unable to elide that copy, for example, in case where the tracer is 2 kilobytes in size, it will default to implicit move. So you don't ever have to move manually. And last thing I wanted to mention, because I really like to use autorefref, there is a one-foot gun tied to it. And many people are asking me, hey, why are you using autorefref all over your articles or over your code? And my reasoning always is, autorefref is usually what you want to do 99% of the time. it is the closest equivalent to var or let keywords from languages like JavaScript or Rust or C# or whatever. But there is this 1% of cases where you really don't want to do this, and this is one of these examples. If you use auto-ref, the compiler will emit an implicit move, whereas if you just use a plain auto, it will elide the copy altogether and will not trigger any move whatsoever. So let's wrap up. And for whatever reason, I'm like 5 minutes faster than every single time I was practicing this talk. So I'm sorry for that, but you will get to eat and drink beer faster. Okay, takeaways. For most of the cases, passing parameters to constructors like constref is usually good enough. But for those cases where you really want every single squeeze of performance, first consider making those copies explicit on expensive to copy objects, so you can then reason about extraneous copies. And second, you can always optimize with universal references. Second takeaway, compiler is free to optimize away constructors. This is not a biggie. Some constructor is always executed. This is just reducing a total number of constructors that happen along the way, but it is good to keep this in mind. And a third thing, I really like constraint auto. I think it makes templated functions in C++20 and beyond really, really nice and legible. So that's all from me, except one more thing. I'm hoping this will not get cringe, but this is basically a third meetup in a row where I end up with I made another game, and great, the GIF stopped working, so you don't see it. Sorry for that. Okay, I will just quickly boot it up and tell you what it is, even though you can't see it. It is a remake of Resident Evil as a solitaire card game. It works on Android and PC, and it's available for free. And if I manage to get my presentation working again, I will at least give you QR links to the slides and to my itch.io page from where you can download it. Yeah, it's working. Okay, that was enough. All right, thanks for your attention. If you have any questions, just ask now. We have plenty of time.
In your example, oh, fancy. So in your examples, why do you actually require the std convertible to and is same as at the same time? Shouldn't the std is convertible to be sufficient for all the cases? Because t is always convertible to t.
Good question. The question was, why am I using same as and convertible to at the same time? The answer will probably be that when I was writing the article 2 years ago, I didn't give it much thought, and I gave it zero thought when I was copying it into the slides right now. Any other question? I get it. You're all hungry and all dried up, right? So if you want to chat, you can chat later over a beer. Thanks for the attention once more. Mm-hmm.